हेलो एवरीवन, वेलकम टू आदिक साइंस अकेडमी। आज के इस वीडियो में हम लोग ग्रेविटेशन चैप्टर को आगे प्रोसीड करते हुए इसके डिफरेंट टॉपिक्स को देखेंगे। फर्स्ट पॉइंट है व्हाट इज द फोर्स बिटवीन द अर्थ एंड द मून। अगर आप हमारे इस चैनल पर नए हैं तो हमारे इस चैनल को सब्सक्राइब कर लीजिए, जिससे आने वाला हर एक नया वीडियो आप तक आसानी से पहुँच सके। सो लेट अस स्टार्ट द क्लास। कैलकुलेशन ऑफ फोर्स बिटवीन द अर्थ एंड द मून। We have already seen the gravitational force. This is the earth and this is the moon. The mass of the earth is 6 into 10 की power 24 kg and the mass of the moon is 7.4 10 की power 22 kg. The distance between Earth and Moon is 3.84 10 की power 8 meter, or you can say 3.84 into 10 की power 5 kilometer. Now using the formula of gravitation, F equal to gmm upon r square. So here r is 3.84 10 की power 8 meters. This is the mass m, capital M you can take it, and this one the smaller m. Capital M mass of the earth and small m is the mass of the moon. Now calculate, putting the value of g 6.67 10 की power minus 11 Newton meter square per kg square into 6 into 10 की power 24 kg into 7.4 into 10 की power 22 kg upon r 3.84 10 की power 8 meter square, and this whole will be calculated in Newton because this is the force. Now 6.67 into 10, calculate the odd numerical value one sided. 6.67 into 6 into 7.4 or 3.84 multiplied by 3.84 because this is the square. Now 10 की power minus 11, this is the added, this will be added because positive powers, into 10 की power 46, 24 plus 22 46, and this is the 10 की power 8 square, that is it will be 10 की power 16, 10 की power 16, and if this will go up it will become 10 की power minus 16. Okay, so if you calculate, this will cut in 2 times, this also cut in 2 times, 6 2 ja 12, or approx 6.67 6 into 7 3.84 3.84. Now calculate the power. This will become minus 11 16 27, so 10 into 46 minus 27, it will become approx 246 approx 220 and 10 की power plus 19, 10 की power plus 19, or you can say 2 into 10 की power 20. This is the approx value, this is the approx value. Okay, approx value, if you calculate it will comes in certain digits in decimals, so this will approx value. So this is the huge power, this is the huge force of attraction, 10 की power 20 Newton, and with the help of this huge gravitational force the earth attract the moon. That's why the moon is get bounded by the earth and get revolved around it. Okay, this is a very simple calculation, and this large amount of force tells about that कि earth exert a large force on the moon and it will attract it will get attracted toward the earth. Okay, that's why imagine the case of the solar system. There are many planets. Sun is the star in the center, and there are many planets. Sun attracts every planet with the help of gravitational force. Every planet has mass and Sun has mass. You can calculate the gravitational force between Sun and different planets. And due to this gravitational force, every planet of the solar system get attracted by the Sun and it get revolve around the Sun. Okay, here Moon and Earth. This is the Moon and this is the planet Earth. So Moon also revolve around the Earth due to gravitational force. Okay. Now the Kepler's law. Kepler's give 3 law regarding the movement of a planet around the sun. Kepler's ने कहा जो planet हैं वो और सन के चारों ओर elliptical orbit में revolve करते हैं. Not in a circular orbit, but it revolve in a elliptical orbit, that is slightly oval. Like this. This is the elliptical orbit, and this elliptical orbit has 2 focus. Focus 1 and focus 2. And Sun is at one of the focus. Sun present at one of the focus. Here is the Sun. And this is the planet which is revolving around the Sun. This is the planet which is revolving around the Sun. So Kepler's first law states that, first law of the Kepler, first law states that the planet revolve around the Sun in an elliptical orbit. This elliptical orbit have 2 focus, 2 focus या 2 foci, that is plural, 2 foci. The Sun remains situated at one of the focus. So this is the first law given by the Kepler's. Okay. Now, second law. So you understand that planet is revolving around the Sun in an elliptical orbit, and it has 2 focus F1 and focus F2. The Sun remains at one of the focus of the elliptical orbit, and the planet revolve around the Sun in an elliptical orbit. Okay. Now second law. The planet revolve around the Sun in such a way that the distance between planet and Sun sweep equal area in equal interval of time. That is, this planet is revolving around the sun, and the line joining the sun and planet is this. So this line joining the planet and sun is the distance between planet and the sun. It will sweep equal area in equal interval of time. That is, if imagine the position A and this is the position of B, the planet position at A and planet position at B, it will take time t for revolution. Now the area swept by planet from A to B is this. This is the area. Area swept by planet in time t is this one. Now imagine the position of here. This is the farthest point. This is the nearest point. The planet is near the sun, and here the planet is farther from the sun. So now the line joining the planet and the sun is this. It will swept an area, this one the area, this is the area, and it will take time t. It will take time t, and the position is A dash B dash. So second law states that the line joining the planet and the sun swept equal area in equal interval of time. So it means that this area and this area is the same. So there must be the motion or the motion of the planet is fastly here, because this is the large distance, large radius, and this is the small curve, and here it is the small radius and this is the large curve. So we can say that in the same time the planet will go from A to B fastly here. Here is fast movement, fast movement, and this is the slower movement. This is the slower movement. So we can say that when planet remains nearer to the sun, it will revolve fastly, and when the planet remains farther from the sun, it will move slowly. Okay? Now the third law. Third law. The cube of distance between the planet and sun is directly proportional to the square of time period, taken by planet during revolution around the sun. around the sun. That is, here the distance between the planet and the sun, that is r, you can say r, and the time is t, so rq directly proportional to t square, to the square of the time period taken by the planet during the revolution around the sun. And to remove this directly proportional, we will use the constant term, constant t square, and if you put here rq upon t square is equal to constant. So this is the third law given by the Keplers. This is the third law given by the Keplers. Okay, and Newton used this formula to give the law of gravitation.